Good morning, everyone.
Good morning.
Thank you for coming. So, how many of you are from the OT, Operation Technology side? Wow, there's quite a few of you guys. How many of you actually never heard of Audi? All right, okay, good.
Our marketing team is doing a good job.
They're doing a good job. But how many of you know that what are the other cars and motorcycle brands that Audi also make besides Audi? Almost right. Anyone want to guess? All right, we review that later on, okay?
Yeah. Stay curious, stay excited.
Yep.
Like Audi is pretty big. Yeah, so let's get started, right?
Yeah. So what we want to do today, we want to talk about the project that we work together, right? A great collaboration between VMware, Audi, and also Audi ecosystem, right? It's a true collaboration between IT and OT side of the technologies coming together to make Audi realize their vision, right? Of building a better car, quicker, higher quality, and achieve more flexibility, right, in their production line by using the software-defined technologies. A quick introduction, right? So my name is Kangwan Chintamit. I work in the product management for the software-defined edge. So we focus on anything outside of the data center. Or in this project, the people they call me, yeah, these are IT guys. Right?
Yeah, my name is Thomas Kamper from Audi. I'm a solution architect. Was working on this project for a couple of years now, so super excited to finally be able to talk about this. It's very transformative in our eyes because it changes an industry that's not easily changed because we like stability. We have friends from Japan here who like the reliability and stuff, right? The same goes for our German cars. We don't really want to change where it's not needed, but at some point now that we are facing new challenges, we came to Kangwan and team and finally found a good solution for our challenges that we are facing today.
All right, so let's get started. I think you guys have seen this probably like too many times. We'll skip. All right, you want to talk more about Audi?
Yeah, so just to give you a quick overview, because the scale of operation is not to be underestimated. We have around 90,000 employees, delivered 1.9 million cars. This is like only Audi. And the revenue is also not too bad, I would say. Could be better, but that's all right. On the right-hand side, we see everything that's part of the Audi group, starting up with the four rings. I think you know them. They are basically the four companies that merged together and created one company, in this case Audi. We have Audi Sport. Funnily enough, this is the place where we started this project, where we used to produce the R8. You might know it from the streets and stuff. Unfortunately, it's been discontinued. Then we have Bentley, which is part of Audi, Ducati. They produce motorcycles from Italy. And Lamborghini, of course. Super great. And since you mentioned VW, we are part of the VW group, and VW is massive. Like, this brings some other challenges, but we won't be talking about this today, no worries.
Yeah, we just happened to pick the factory that built an expensive car, low production volume, right? And that way we can actually get experience, right? And without having to introduce too much risk into production time and so on. All right, so let me talk briefly about what is going on, right? And I think hopefully this is something that you guys can relate to, that a lot of the customer we talk to, they want to introduce the word smart into everything they do, right? Smart manufacturing, smart factory. What it means is the integration of technologies into the production line or the shop floor, right? There's new workload, new applications, new use cases that are being brought in. But then it also creates another problem, right? Which is the more technologies you bring in to the OT side that used to be traditionally air gap or disconnected, now you create this attack surface that you need to be very careful about, right? I think some of you may have been through that and experienced that not just the ransomware can bring down a factory or a PC, but also a bad patch can actually take and stop many things, right, including the factory. And then last is the sustainability, right? Everyone wants to meet their sustainability goal by reducing the carbon footprint and also reducing the number of devices. But what actually is happening is almost the opposite, because the typical way of how the production team or the operation team look at the problems, right? They have to solve the problem very quickly. So they go and acquire new technologies that may be new hardware. Now they bring into the shop floor, they integrate it, they move to the next project, right? So now they could end up with a lot of different technologies and devices that they end up having to manage, right? And as Dr. Henning, which is, we work with pretty closely, right? He likes to say, hey, when I need a new function, in the past, I need to buy a new device for every new function. What I want to be able to do for Audi going forward is when I need a new function, I add a new piece of software, right, to a platform that I have. And that's sort of like trigger, right, this project that Thomas will talk more about.
Exactly. So the project is called EC4P, Edge Cloud for Production, kind of a fancy title for a German project. Usually they're very boring. This is the best the marketing team came up with. So what we have here, we try to take all these IPCs that we have in the shop floor and consolidate them in so-called edge clouds. It's basically like mini data centers really closely to the factory, like a couple 100 meters up to maybe 10 kilometers. On the right-hand side, we see a little split between non-RT, RT stands for real-time, and RT workloads. These are pretty typical. We have quality assurance, MPC is like a screwing application, MES, if you're familiar with that, manufacturing execution system, really typical things that you will see in every factory. And on the other hand, and this is pretty exciting, we have the virtualized PLC, programmable logic controller. We'll talk about this in more detail in the next couple of minutes, just like a teaser where we are heading to. So this unified platform to drive innovation, right? But also manage this nightmare of patching and new applications.
All right. So we know that the project is taking off when we fly everyone together, right? From East Coast, US, Germany. And this is actually, we took this picture in Palo Alto at the VMware offices when we get everyone in front of the whiteboard, actually a flip chart in this case, right? And then we start talking about, hey, what do we need to do? And the problem is not just a technology problem, right? It's also a personal, and how do we actually integrate it into an OT environment without freaking out everyone, right? That we're changing something drastically or changing the process of what they used to, how they used to operate. So this is the start of the project essentially. And so now let's talk about how do we actually start, right? Because we start gradually, right? So that way we're not disrupting too much. We introduce the technologies and then from the easier one to the more difficult one, right?
Exactly. So just to give you like an understanding of the scale, put some numbers and pictures into your head. We have 4,000 HMIs. These are the like human-machine interfaces for humans to engineer, to look at some data, right? At the same time, we have IPCs, over 10,000 in a single factory. IPCs are nothing else but like industrial-grade PCs. You can run Linux, Windows, or whatever. On these boxes, they're very flexible, but at the same time, you have to patch them. They can break down, so there's no high availability inbuilt, right? Then obviously robots, lots of things are automated, especially when you're in Germany. You have to automate as much as possible because human labor is quite expensive, as you might know. And then finally, this Gray box on the right-hand side is the PLC. Looks like it's coming from the 70s. They like changing the shade of gray from like light gray to dark gray, but that's basically it in the past years. So if you've worked with them 20 years ago, you will still be able to work with them today. There hasn't been much change whatsoever. So this is like the environment that we're trying to work in, and just look at the numbers. It's really hard to manage all of this, and then it keeps growing. So we have more applications. People want to innovate, make the cars better, more reliable. This is obviously not easy to solve.
All right, so essentially we start, as I mentioned, right? We take baby step. So a lot of the workload as that you see is sort of non-real time. Right? Because if you think about it, the industrial PC, a lot of them run like Windows, right? And when they break down, this is the first time I heard the term sneakernet, right? Which is some guy actually run over to the IPC, try to replace it, put a new operating system on it, right? 40 to 45 minutes to actually install an IPC over CD-ROM or USB. And meanwhile, the production line may have to be stopped because that PCs happen to control screwdriver application and so on, right? So, and then there's some other application as well, right, that Thomas talked about, like the MBS or the HMI, that basically display information for the worker on the final assembly so that they know what they need to do on that machine. And then the last one is the UPS, right, which is the test and diagnostic applications. So these are sort of like an easy target for us to, hey, let's go ahead and virtualize them. Right now you create a golden image that when you need to spin up a new instance of the IPC, is now just a VM. A lot of us on the IT side sort of take it for granted, right? Hey, what's new here? We have done this like for many, many years now. But I think the key here is how do we introduce this technology to the people, the technician that are using this product on the shop floor, right? And introduce it in such a way that they don't see that there are changes or too many changes going on. So at the bottom, you can think of this as, this is where the final assembly is. And this is where we replace the IPC with the thin client, right? Running iGel thin client software, and then basically connecting to the instance of the VM that are sitting on EC4P cluster. But the difference here is, even though we refer to the term VDI, we don't use VDI like in the sense of VDI that you connect into a gateway and it gets redirected to some VM. The mapping between the station that the worker is a one-to-one mapping to the VM that's sitting on the EC4P. But now you instantly gain the benefit of the bring up is 1/3 of what it used to be, right? You just clone an image. When a server fails, the VM automatically move, right? Because of the VMware HA. And then the other nice thing about is now you have snapshot, backup, and now if you're affected by malware or bad patch, they can easily revert back to a previous version. So now, but from the technician standpoint, they see exact same thing, right? The same screen that they used to see, it's just behind it, instead of being an IPC, now it's a thin client. So it doesn't change the way they used to interact with the system.
And this is super crucial. Like the look and feel for the worker itself doesn't change at all. Usually it's just faster. Before, the PCs are very low powered, like in terms of CPU and stuff, and now it just reacts so much faster, even though the compute has been outsourced into like a local data room, right?
All right. Yeah, but one thing we take very good consideration into is the latency, right? Because in the end, the worker has to interact with that machine, and we don't want them to feel that, oh, this is something far away.
Right, and there was like a boundary of like 25 milliseconds in terms of latency, where they will notice, okay, something is not quite there. So this is what we roughly have as a boundary. We have to stay below that number.
All right. So now the other thing is that we did this is also we want to get the EC4P team to start learning how to operate this new infrastructure. Because again, this is the team within operation technologies, right, that have to maintain this infrastructure going forward. So there's some learning curve, right? There's some change in the SOP that they need to learn and follow.
And that's also a good point. We actually do the operations in-house, which is kind of unusual. Usually our IT is outsourced, like think India and whatnot. But in this case, we are doing it all in-house, which greatly benefits. They have an intrinsic motivation to actually improve the platform, make it more efficient in what they are doing and stuff. So that's been really successful so far.
And you guys actually built a brand new team just to do exactly.
Exactly. Yeah. Like I'm not taking care of that. I'm just the guy painting some boxes and stuff, but my colleagues are really good, so
all right.
Luckily.
Okay, so now it sort of built a foundation for us to move to the more difficult one, right, which is the PLC.
Yeah, so the whole real-time aspect, which is obviously super exciting, right? I know most of you guys know what a PLC is. I'll still really briefly talk about it. So you can think about it as like a pacemaker. It basically runs cyclically some kind of arbitrary code. It takes inputs from the shop floor, like some sensors or actuators. Then it runs through it. This will take maybe like 5, 10, 15 milliseconds, like give and take. And once it's done, it pushes the output to, let's say, a robot. Like right now, there's a light sensor and a car is coming in, so now the robot knows, okay, it's time to put the door in there, stuff like that, right? And this happens, I don't know, like 100 times per second. So they run 24/7, sometimes even for years. Like there's like, this happens too. But this is basically the heart of every factory. This keeps everything moving and is super critical. Once a PLC breaks down, everything comes to a halt at this area. And it's also responsible for safety. So there are robots in place. They are bigger than me. They are much stronger, and they will knock you down if you come too close to them. So we have like some safety measurements. The PLC is taking care of that as well. Just to give you an understanding, like there are also other industries, obviously, that would benefit from a virtualized PLC, starting out with some substations like utility sector, all of that, good thing. Food and beverages, like I'm German, so I'm very interested in having my beer for like Oktoberfest and stuff like that, right? Building automation, and finally, obviously, manufacturing. I think there's even more examples just to give you an overview, right? It's very versatile. Now looking forward to what we're trying to do, and this has been attempted before, right? Many people have talked about this like 10 years ago, 20 years ago, but nothing really came out of it so far. What is different this time? We believe we have this really strong partnership, not just with VMware here, but also with the PLC vendors. In this case, it's Siemens and Codesys, which are really famous all over. Codesys, maybe lesser known. They only provide the software, and then usually some other company will white label their PLC and sell basically the box, right? So what we did here, we took the PLC, it's in essence just a Linux VM, put it in this case on ESXi because our people, they know ESXi. We used VMware technologies for many years, so it would be ideal if we can still use it in the forthcoming future. And this obviously puts some requirements on the infrastructure. So now we have the first requirement, which is a real-time capable virtualization platform. Because as I said before, this is running deterministically, let's say 100 times per second, right? So this has to be really fast, and we can't really have any outliers. If it takes too long to respond, everything comes to a halt. The second thing is the virtual switch. Eventually, we have to take the packets out from the VPLC over to the robot, and this has to go through some kind of virtualization piece, which in this case would be the virtual switch. Here it's really important to keep the latency, jitter, etc. low, because I don't really want to work with outdated data or push some commands and then the car is already somewhere else, right? The next thing, and this is also a huge one, is the whole topic of resiliency. So now we are outsourcing PLCs. They used to be like maybe this far away, right? And now they are like a few kilometers or a few miles away. So the entire area between can create like a fiber channel cut or whatever. And this we have to prevent, obviously, from data not coming from A to B, because again, it will stall or halt the whole factory. And finally, as I said before, the robots are like really mean. They don't care about you. So we need someone to protect us from them. This is, again, the job of the VPLC. In this case, the safety function of it. So these are the major requirements, a couple more, but these are the most important ones, which we handed over to VMware and like asked, can you do this, basically?
All right. So let me touch quickly on what we had to do, right? Number one is, okay, get a deterministic compute, right? And this is something that is not new, right? We've been having this functionality since 7.0 update 2, and it's been improving. So in the past, there's a lot of misconception, right? That, oh, you guys cannot run any real-time workload because the hypervisor adds a lot of the overhead. And that is actually not true, right? We have been tuning the product for quite some time, and actually has been in use in some other market as well, like in the 5G radio network actually can run on this platform. And we take advantage of the same optimization and use that for the PLC. So I know this chart is maybe a little bit harder to read, so I'm going to try to explain it to you. And we use the test called cyclic test, which is a pretty simple Linux program. So it measures the difference between when the application wants access to the CPU to the time that it actually gets access to that CPU. And that is basically the overhead or the latency. So now we use the same operating system. We put it directly on bare metal. And then we run the same operating system as a VM on ESXi, configure with this low latency capability. Now, the way to read this is a logarithmic scale, and it's a histogram. But the thing that you need to pay attention to is what is the max latency that it is getting introduced. You see that on the left, which is on the bare metal, it's roughly the max is around 75 microseconds. And then with the hypervisor, we actually get it even lower, right? In some cases, 45 microseconds, but you can actually utilize all the core of the multi-core CPU to run your VPLC. That means you can now pack multiple instances of the VPLC onto a single server and now take advantage of some consolidation. The other thing that we need to solve that Thomas talked about is the network latency and also the reliability, right? Because now the VPLC, I'm going to try to bridge out here. The PLC used to be connected directly to the robot cell, to the switch. Now you're taking it away, right? Moving it to a server that may be sitting in the server room on the campus at Audi campus. Now there's some increasing in distance between the PLC or VPLC and the robot cell, and it has to keep sending commands. In this case, we use industrial Ethernet protocol called Profinet, right, which is supported by the VPLC and also by the I/O devices. And now we had to do two things. One is we need to make the virtual switch low latency, right? So that way, the latency budget that we get from Audi, we need to stay below 250 microseconds total. right? I think we good on the compute latency, right? And now we need to worry about what is the network latency in the virtual switch. The other thing that we need to do is, you see sort of Thomas talked about the diverse path of the fiber between where the EC4P cluster is and where the robot cell is. So now we need to make sure that we don't lose packets, because if you're sending command to move the robot or tell the robot to stop and we lose the packet, this can be bad things to happen, right? So we actually implement a protocol called PRP, which is a standard that stands for Parallel Redundancy Protocol, into the virtual switch to overcome this problem. And then Thomas can talk more about how it works.
Right. So PRP is a great example of this IT-OT convergence that's happening. It's a really classical OT-based protocol, layer 2, MAC addresses, and all the good things, right? And these guys actually implemented it in the virtual switch, which is fantastic for us because it provides the static redundancy. It even improves latency, because you will see in a second. I have a little graphic or animation. In this sense, we want to send something from VPLC A all the way down to the robot down below. What happens when a packet is being sent out? It reaches the low latency vSwitch. It's being duplicated by means of PRP. Like every packet that's incoming, it will be duplicated. Then it crosses the entire network. And I made it really slow for you because otherwise you wouldn't be able to see it. It takes less than a millisecond from all the way at the top to down below. And what's also interesting here is we have these fabrics which utilize VXLAN. VXLAN is more like a data center technology, but you also see it now more and more in the campus. What it basically does, it takes the packet that you originally have, in this case our Profinet/ProfiSafe packet /PRP packet, and puts it in an envelope. In this case, we can route it over a layer 3 fabric, IP-based fabric, and then decapsulate eventually. Now it reaches the industrial switch. We still have industrial switches in our robot cells, and these can deduplicate because they are also PRP capable. So in this case, the green packet was there first. It gets sent to the robot and is being consumed, whereas the blue one is just thrown away because we don't need it anymore.
All right. Yeah, so this is a way for us to increase the chance that the packet will make it to the other side, right? And also, there's no failover here, right? Because the same copy of the packet are sent over 2 paths. And if one fails, you still have the chance that the other one will make it. So now let's talk a little bit about how we actually did it, right? And again, I mean, it's not like I'm doing all the work. I mean, this is like a big team effort, right? From engineering and solution architect, the customer, right? And also the partner working together on this. We take something called the ENS, which is part of our NSX switch. And ENS stands for Enhanced Networking Stack. And in the past, it was optimized to push a lot of packets, right, for high throughput. Now we're actually changing it or give it another mode to optimize for latency, right? So low throughput and low latency and predictable, right? Meaning that we want it to be deterministic. So the goal is to hit 250 microseconds budget that we are given by the customer, right? That in this scenario. We also have to add support for Profinet, and Profinet is industrial Ethernet protocol, right? It's been created some time back. It doesn't actually care too much about how the virtualization works, right? So, for example, it actually adds the 802.1p header. It adds the VLAN tag, but the VLAN ID is 0. So when it goes to the virtual switch, the default behavior is, I don't know what this is, I'll drop this packet. So we have to actually make some changes to recognize and be able to treat the Profinet frame accordingly. In some cases, when we have multiple VLANs, because each VPLC could be controlling different robot cell, so they sit on a unique VLAN, and then we have to also rewrite that packet without making that port a trunk port, right? So there are a couple things that we have to do there. The other thing is around the DCP packet. This is the discovery protocol that Profinet uses to discover the devices. It's multicast, but it doesn't actually register the multicast MAC address. It expects that when it sends the frame out, it wants the virtual switch to broadcast it. So we have to make some changes so that we don't need to use promiscuous mode. Right? So these are the things that we have to adjust to support the industrial Ethernet protocol. We also make some name changes, right? So I think you saw, sometimes we call it low latency vSwitch. Some of us got creative, changed the name, now call this industrial vSwitch. So you may have seen some different names being used, but they refer to the same product. We started with 12 VPLCs, and this is actually based on the CPU that we chose for the project, which is a 32-core single socket. And the VPLC at the moment, based on the way we receive it from our partner, it basically used 2 cores per VPLC. In the future, there can be a way to actually increase the density, but that's how it is today. So now this is sort of the measurement that we have done, right? So we run 11 VPLCs, supposed to be 12, but now we need to use one of them for safety. So we need to dedicate one VM to provide the time service to all the other VMs so that this VPLC can now become a safety VPLC. So we lose one VM for the time service function. So that's why in the test you see that we are actually running it with 11 VPLC on this hardware. And then if you look at the latency, and this is the maximum latency in the transmit and the receive direction, and basically it's still well below the 250 microseconds. And the way we actually achieve it, I forgot to mention, is we try to make as much localization of the CPU core that the virtual switch actually uses. So when the packet comes in from the VNIC, right, the VPLC send the packet, we go into the virtual switch, do a lookup, encapsulate it into a PRP. We make sure that it is processed by the same CPU core. And that way there's no cache misses, and that's how we minimize the latency. And we do that in both directions. Mm-hmm. So now I want to, Thomas, can you talk about the video that we have at the bottom, what happened here?
Yeah, sure. So we used a single, in this case, it's just a single VPLC controlling a single robot cell. A robot cell, in our case, consists of multiple robots. I think it's like 8. This ran through for an entire day, no interruptions. We have also some VPLC instances running since the beginning of the year. Again, no interruptions here, so that's really cool. Even the people that are using them actively are also really surprised about the performance. Like everyone is like, how is this even possible? Or like everything is moving faster. Like we are not just doing the VPLC here, but also the HMI, where we have the Fin client, coming back to the non-real-time side. We have the Fin client, where the Fin client connects to our cloud, our edge cloud, and provides the same engineering tools that you are used to. So for the look and feel is the same / better than before. And yeah, great video, I think. That was from our plant here in Germany. And we hope to see more of those in the future, or also other use cases, obviously, realized with VPLCs.
All right. So now it's sort of maybe a quick summary, right? So we talk a lot about, or maybe the industry, right? Talk a lot about IT and OT convergence. And it's not about running IT and OT workload on the same box. Right? And there still has to be some demarcation. And if you look at the way that we did this project, it's standardized on the same type of stack, the same operating model, the same processes. And you can see that there are still different clusters for different purposes, and they are tuned differently, right? Different configuration and permutation to address the specific use cases. But from the operational perspective, we are able to actually have the same operational model and address different type of use cases on the shop floor. And then that's basically sort of the idea, right, that Henning had in the beginning is when I need a new function, I add a new piece of software, could be VM, could be container, but I keep scaling out my platform, right, to become something that eventually addresses everything that I need, right, in my factory. So sort of looking forward a little bit, right, I think we are still at the very beginning of this. And we start with Profinet, right, because that's also what Siemens is pretty well known for. There's some other industrial Ethernet protocol as well, right, if you need to take a look at, and it's depending on the type of use cases, the PLC that you use, or the protocol that you use, right, like Ethernet IP, EtherCAT, and so on and so forth, right? But again, these are layer 2 industrial Ethernet protocol that can be adapted to what we already did with Profinet. End-to-end monitoring, and I think this is something super critical, right? That we don't cause the finger pointing, right? Because we have the probe that we put inside the virtual switch so that we can measure the latency and prove ourselves innocent, right? When something bad happens, we can actually go back and look at, hey, it's not caused by us. But end-to-end monitoring, because there are multiple components in this case involved, right? From the virtualization layer to the network fabric to the network within the robot cell itself that we need to be able to measure the end-to-end latency.
Right. So maybe also like summarizing where is the EC4P platform located. It's a perfect example for this IT-OT convergence that's happening. We are able to now scale horizontally easily and also deploy new functions for the shop floor. So we are kind of providing a service for our colleagues that are actually manufacturing the cars. Right. We still have our on-premise enterprise domain platform where we have like NTP, DNS, like all these basic services. You still need them. I personally don't want to be responsible for them, so we are outsourcing that and centralizing it. And at the same time, there are certain workloads where you want some kind of flexibility. There, we are leveraging hyperscaler like AWS, whatnot, right? Can you go to the next
one?
Yes. Right. Just to give you some sort of inspiration, what else could be done and how we are seeing this industry moving forward. The first one I personally like a lot because I'm somewhat in the planning department. And when we are planning, we usually use pre-commissioning based on virtual like simulation of robots and stuff. In this case, now we have VPLCs and there's also virtual robot cells available. So it's much easier to run through these simulations, already set up these robots because you have to teach the movements and stuff. Especially with a new car coming out, there might be some major or some minor adjustments, and this can be also really easily be done on our platform. Now on the top right, this is maybe a little bit of a hot take, but we believe that VMs will be staying there for a foreseeable future. There are just too many dependencies on something like Windows, and I'm not sure there are like Windows-based containers, but who really wants to use them, right? So in the long term, we believe there's like it will even out between VM and container. Kind of depends on the application that you have. Right now, we are in the lift and shift era of our project, where we basically take everything that's in the factory, put it in the platform or on the platform. Next up, and we are also working already on that, is the refactoring phase, where we take the applications that are predominantly being created for IPCs and stuff, and refactor them for a like IT/cloud native environment. So think Kubernetes and all the good stuff. And finally, lots of new applications that we want to tackle. We started out with a few dedicated ones because they're a lot of, let's say, MES clients or PLCs, but there are still other applications and domains that we want to focus on. One of them is, we call that AI robotics. We have to use the word AI eventually, right? So now's the time. Ideally, we want to keep these robots as stupid as possible, and again, outsource anything that's compute intensive into an edge cloud. Then we have basically the same requirements, low latency, basically real-time requirements that we have for the VPLC as well. And the same holds true to some degree for the ML, computer vision stuff. There are lots of people who want to do stuff with that, but at the same time, we don't want to put IPCs at every tact. Like it will increase in, like we saw the challenges at the beginning, right? It will increase in the amount of maintenance that we have to conduct. And we provide now a platform where you can just say, okay, I need a VM, want to do some new fancy machine learning or some predictive maintenance and stuff. You can easily do that on our platform. So to wrap up from my end, what's next for our project? We are basically scaling in all dimensions. So far, we have been working in the body shop, which is like HMI and VPLC focused, and the final assembly, where you see MES, system, UPS, the screwing applications, and so on. But there's lots of other things where you can scale, where you have new applications, and lots of benefits in the future. I'm personally excited for the logistics because it's such a broad area. It brings all the pieces together that we already have. So that would be cool. And yeah, other locations as well. We have multiple brands under the VW group. Everyone is eager to try our platform out. So I think I'll be back and talk about this at some point.
All right. Okay, so I think, yeah, just also want to mention quickly, right, from the product perspective, there's a lot of focus on AI now, right, that at least from the software-defined edge division, which is I'm a part of, right, focus on how do we enable AI, edge AI by providing you guys the infrastructure, right, and eventually be able to link that in with the network and the underlying infrastructure, which could be the WAN that are coming from the telco. So I think with that, it's a wrap, right? I think we have maybe a couple minutes left for Q&A. We'll be around for a little bit, right? If anyone has any questions or comments, right? Again, I think as Thomas mentioned, it is a journey and it's a beginning, right? And they just need the industry to come together. Like just before this session, we were talking to Exxon, right? That are actually, they had a talk this week as well, right? About something similar going on in the process manufacturing industry. And this is discrete. So I think it's pretty exciting time, right? For the industry that things are transforming and to be more software defined, right? So with that, I think, thank you everyone for coming. I hope you have a great time and enjoy the rest of the Explore.
Yep, thank you.